Thank you, Ashok. On behalf of the project, we want to express our gratitude for your and your team's involvements and assistance. Everybody, welcome to this presentation of Oracle's NoSQL database Maximum Available Architecture, MAA. Let's present the team involved with this concept.
Welcome. I'm Stéphane Duprat, and I've been working with relational databases for almost 25 years.
Hi, I'm Dennis Federico. I've been working with Java for the last 14 years and with big data technologies for over 5 years.
And I'm Michael Ellison. This presentation is divided into 4 sections. The use case, the project where this concept was conceived, why MAA, why reliable data, how it works, and a brief demo. This solution came from a real client's use case. We generalized it so others may see its benefits in their own businesses. This customer wants to analyze their business activities in real time. Anyone in the retail business or in the logistics sector can understand this need. Especially with the holiday shopping season upon us, Cyber Monday, Black Friday, you can understand the benefits of analyzing your business activities in real time during periods of intense activities. To achieve this, their remote offices and regional sites must send their business activities in real time. These activities, these transactions, are received by a corporate data dock, a transaction receiving center, a store fast enough, reliable enough to handle vast amount of individual transactions. This data dock is Oracle NoSQL. Their real-time applications are implemented with other Oracle middleware products like Coherence, which requires a persistent store. Again, this is Oracle NoSQL.
Whenever you incorporate a new technology into your data center, you obviously study its featured functionalities. You must also study its compatibility to keep your business continuity. Business continuity as your infrastructure resilience to disturbances. So, this new technology must be consistent with your business continuity and the investments made in your data centers, like high availability and disaster recovery. You cannot afford to introduce a weak link that could increase your system's susceptibility to outages or data loss. Oracle NoSQL database has been conceived with high availability and disaster recovery in mind. The maximum availability architecture is a blueprint of the best HA and DR practices based on expert recommendations and customer experiences. In our demo, you will see an application's resilience to switchover, maintenance outages, and a secondary data center failure. And a primary data center failure that requires a manual intervention much similar to a data guard failover. We claim HA with no data loss. We will explain it and prove it. Ask the representatives of other NoSQL products if they can make the same statement.
To understand NoSQL MAA, one must understand the functionality of the product itself. Here are some basic concepts. A zone is a grouping of machines with good network connectivity. Let's draw 2, each in different sites. These zones can be either primary or secondary. The replication factor of a zone is the number of copies kept. 3 is a typical number used to ensure replication and to ensure a quorum vote produces a majority. A primary zone will host the master copy of a piece of data and maintains a quorum to enforce consistent operations. The secondary zones only contain data which can only serve as replicas for reads. A switchover is the interchanging of zone roles in a fully operative system, for example, like we have currently drawn. A secondary zone failure does not have major impacts for the reasons stated earlier. For example, if this site fails, the system continues to operate. If the primary zone fails, we must perform a failover, which tells the surviving zones to remove a quorum and to downgrade the failed primary to secondary. This is the foundation of NoSQL MAA. Dennis will discuss the concept of durability, which will tie everything together. And now Michael will change this topology.
Be a small conceptual change. Let's provide the NoSQL administrator with controls and options to resolve issues. A zone is a logical construct which aggregates physical elements. Let's split these zones with RFs of 3s into 3 zones of RFs of 1s. All this is done by dividing logical constructs. Let's make one more change. Let's move one primary zone. Having a primary zone in each of the 2 sites is very important in MAA. Obviously, the administrator now has more maneuver room. One last point. We need to redefine the standard concept of primary sites. You see, both sites have primary zones. But the primary site is that which has a simple majority of primary zones, while the secondary site does not.
The durability of NoSQL can be compared to committing a transaction in an Oracle database by writing into the redo logs. The application does not receive an acknowledge from the KV store until the desired durability is achieved. There are 3 levels of durabilities in terms of acknowledges. Let's see with our example where we have a replica factor of 3. With an all replica acknowledge durability, all 3 replicas must acknowledge the received data. With simple majority, at least 2 replicas must acknowledge to meet this condition. And lastly, with no act from replicas, only masters participate, but we don't include this in the maximum availability architecture. Let's compare NoSQL durability with DataGuard's protection modes. Maximum protection is like all replicas acknowledged. It guarantees the secondary site has committed transactions and will block application until this occurs. Maximum performance is like simple majority. The secondary site may not have the latest committed transactions, but the applications are not blocked by secondary site failures, which leads us to maximum availability. The native NoSQL driver does not support this and may require a change, but we have prototyped this change. We ensure no data loss while the secondary site is active, and we don't block the application if the secondary fails. Just like with DataGuard, you choose your level of protection.
Okay, let's have a look at our 4 topologies. In the name of each topology, the capital letter represents the primary site, as defined earlier by Michael. A lowercase letter indicates that the secondary site contains a primary zone. These are the standard topologies for business as usual. And these are the topologies for planned or unplanned outages. These 4 topologies are created in the KV store, but only one is active at a given time. The default active topology is top AB. Now, let's explain a seat switchover. We plan an outage on site A. Therefore, we execute a switchover from top AB to top B. The animation shows how some zones are switching their type. And once we are done with the maintenance tasks, we switch back to top AB topology, which is our normal operations topology. Note that the steps we have just explained would be similar in case of an unplanned outage, but the failover command would perform additional actions to ensure quorum consistency. And now, Mike, let's introduce the demo.
This demo is based on an actual deployment of 2 big data appliance starter racks, each in separate sites. 6 nodes in each, 4 networks in total, 2 InfiniBands and 2 Ethernets. This demo simulates 2 sites, 4 networks, but only half the nodes, 6. We shall fast forward the videos to best utilize our time. Additionally, to facilitate the maintenance of a KV store, we have NoSQL-CTL, a proof of concept utility. Here's a quick overview. With a minimal amount of setup, you can create, start, stop, remove, switch over, failover with a single command in the entire KV store cluster. The network and host sections will configure the etc host files in the entire cluster, ensuring proper traffic in each of the networks. This topology set is created with each of the KV stores. The prime topology defines the structures and the zone types, while the additional topology only reconfigures the zone types. These are the 4 topologies mentioned by Stefan. Here we have 3 KV stores utilizing the same hardware. each with default values with the exception of ports and disks. Here's an example of a KV Store administrator starting, stopping, removing, and creating a store. NoSQL connects to each of the nodes and performs the appropriate action. For further information concerning NSQL CTL, this prototype utility, please contact Ashok.
Let's say you have a planned outage on your primary site for the weekend. You will want to reconfigure your topology online. We will switch over to top B for the weekend and then back to top AB, all the time keeping the application running. To save time, we will fast forward the video. Notice how the VirtualBox machines are shut down and restarted. Notice how NoSQL is always running. Now let's verify the rows processed by the application and compare it to the rows in the KV Store. We query the KV Store row number from both sites and compare the results with the number of rows inserted by the application. They match. We have just reconfigured the topology twice online, and that was transparent to the application. No downtime, no data loss.
In order to easily compare the counts, we will stop the KV Store, remove it, and recreate it. Let's assume your site B has failed unexpectedly. You will notice how the application drops from maximum protection to maximum performance. Because this could last several hours or days, we'll want to return all 3 primary zones to site A. We will call this a site-level failover. NoSQL control will launch all the appropriate commands. Now we see all the primary zones are inside A. Notice that the application returns to maximum protection. When site B gets online again, we'll want to return to our standard configuration. First, we must fail back and reincorporate the failed zones. Note that all the zones are active again. Now we switch over to site A. Notice again the zone status. Let's compare counts once more. No data loss, no application outage, and we're back in business, as usual.
We hope you enjoyed this presentation. We've explained Oracle's NoSQL maximum available architecture and demonstrated it. We proved it. Dennis, Stefan, do you have any closing remarks?
Oracle provides a NoSQL solution that complements your Oracle Database DataGuard solution with no data loss.
Oracle provides transparent, no data loss and no service loss features in its NoSQL solution, as we have demonstrated. Can any other NoSQL products make this same claim?
Oracle NoSQL database. It's big, it's fast, it's reliable. It's worthy to be in your portfolio, and you can trust it in your data center. Enjoy the rest of your visit here at Oracle Open World 2015.